introduce Vanessa Simmering. She's a faculty member in Human Development and Family.
Psychology, sorry.
And pardon me, what?
Psychology.
Oh, and psychology.
I know, we're all a little close together too.
Yeah.
Overlapping interests.
Yeah. And she's going to speak to us today about children's understanding of spatial relations and the language that goes along with it. What are the factors that help with children's understanding, and what her research is about at this point.
All right.
There you go.
Thank you.
I'm going to pass around the sign-up sheet, so please put your name and contact information.
All right, so thanks for coming today. What I'm going to tell you about today is just one line of work from my lab. This is a relatively recent line we've started. So I've done work for quite a while looking at children's visual and spatial representations, but this new line of work is understanding how that relates to language development in particular. And so to begin with, I want to acknowledge first that this work is largely driven by my graduate student, Hillary Miller, who's in the audience. So her interest in language is really what has taken my work in this direction. And then the first study that I'm going to talk about, we collaborated with Haley Vlock, who is a professor in Ed Psych as well. And I also want to acknowledge the funding that made this work possible, in particular the core grant here at the Weissman Center that helped with participant recruitment. So as I said before, I've been interested in the development of spatial skills in my research for quite a while. And spatial skills really represents a range of abilities in which children represent, remember, and understand the relationships among different objects and features. And so we can use spatial skills in a lot of different ways, and I'm going to show you some different examples of lab tests that we use to assess spatial skills in young children. One of the reasons people are interested in understanding spatial skills better is because they've been shown to predict children's achievement both concurrently and later in science and mathematics in particular. So we're interested in understanding what it is about spatial reasoning and spatial understanding that might support those academic skills later in life. And we know from a number of studies that individual differences in spatial skills emerge during early childhood. So a lot of my work looks at preschool-age children because this is an interesting time when lots of different skills are developing. And for those who are interested in developing interventions, it might be a particularly beneficial time because studies have shown that you can get more impact or more change relative to the intervention when you intervene relatively early in development. So what I'm going to talk about today is the work we are doing looking at how spatial skills are potentially supported by spatial language development and what role language might play in children's developing skills. So in the literature, there's two types of evidence suggesting that spatial skills relate to language development. Some studies are correlational, so they look at the kinds of spatial words that children know and can produce or comprehend, and then look at those same children's spatial skills to see what relationships exist. But there are also experimental manipulations where you can provide language to children and see if that augments their performance. So I'm going to describe some examples of each of these. But from both of these kinds of work, the literature seems to suggest that there's a verbal encoding mechanism underlying the relationship between these skills. So that as children learn different kinds of spatial words, they can use those words to represent visuospatial information, and that can support better performance. And so I'm going to be talking about our approach is to question whether verbal encoding is really the right mechanism here, or if there's a different relationship, a third factor that underlies the relationship between language and spatial skills. So evidence that children's production of spatial terms correlates with their spatial skills comes from a number of different tasks. So one study that has shown multiple spatial tasks that relate to children's spatial language was this study by Pruden and colleagues. This is the children's mental transformation task, which I'll talk about a little bit more later because we've used this in some of our studies. So in this test, children are shown the pieces at the top and asked if those went together, what shape at the bottom would they make? So this is a task that requires imagining the movement of those pieces and what they would form together. Another task used by Pruden and colleagues was the spatial analogies task. In this test, children are shown pictures like these, So that picture at the top, they're asked which of the 4 choices at the bottom goes best with the one at the top. And the correct answer is defined by the spatial relationship between the objects in the different displays. So in this case, the bird is above the tree, so the correct choice is the one where the dot is above the circle. So that's an example there of how spatial language might help you do that task. Another task they used is a standardized assessment called the block design task. So in this task, children are shown pictures like the one I'm showing here and asked to take those blocks at the bottom and make them match the picture on the page. So the blocks have different combinations of black and yellow on each of the sides, and the child's task is to turn around and find the right pieces and put them together in the right relation to match the picture. So in the first 2 tasks, we just look at children's proportion correct. In the third task, we look at how quickly children can solve this task. So that's the standardized assessment. And I'll note that this block design task in particular is known as an assessment of nonverbal intelligence. So it's interesting to see that it correlates with spatial language and that children might actually be using language to solve this task. So the Prudence study showed they measured children and parents playing together, the number of spatial terms that they produced when playing with different kinds of objects. They measured that at 46 months and showed that that predicted children's later spatial task performance at 54 months. So this was a correlational and longitudinal study that children's earlier spatial word use predicted their spatial skills. Using a different kind of task, Herman Vasquez and colleagues have shown relationships between language and search performance. So here's a task where in this rectangular room, those 4 blue dots represent 4 potential places that an object might be hidden. And the red line indicates one of the walls is a different color from the other walls. So there might be 3 white walls and 1 red wall. So the way this task works is you hide the toy in one of those 4 corners, and then you disorient the child so they can't remember which way they were facing, and see if they're able to successfully search in the correct corner. So this task is a little bit interesting in how it develops. Young children, actually about 2 years of age, don't use the red wall in this task, so they have a hard time finding the toy even if it was next to the red wall. They seem to only rely on the shape of the space. But in this task in particular, they showed that children's spatial language, or their ability to produce spatial words, related to their performance in this task, and that was actually with slightly older children. A similar task is using this array of cups in a circle and using this little puppet as a landmark. And the same kind of task where you hide the toy in one of the cups, you disorient the child and see if they can use that landmark to find where the toy was. So both of these kinds of tasks show that in slightly older children, so this I think was 4 to 6-year-olds perhaps, that their production and comprehension of words like left and right correlated with their ability to correctly search in these tasks. So again, suggesting that they might be able to use that language to find the correct location. And then a task from our own lab was looking at children's use of an intrinsic reference frame to remember a location. So this is actually similar to that last task I showed you. So we have a small rotating table, and we have this array of 5 cups and 4 stuffed animals that serve as landmarks. We hide the toy under one of the cups, but rather than disorienting the child, we have the child turn their back and we rotate the table while they're not looking. And 4-year-olds find this very difficult then to find the toy after you've rotated the table. But we found that if we ask children to describe where the toys are hidden, their production or description of the landmarks in the task, so saying something like the cup by the frog, was correlated with their search on those trials when it's the hardest to find where the toy was hidden. So those are the correlational studies showing that children's abilities to produce or comprehend spatial words relates to their spatial skills. There are also experimental manipulations in which you provide different kinds of verbal information to children to see how that supports their spatial task performance. So in our study, looking at children's use of the intrinsic reference frame on that rotating table, in addition to showing that correlation between children's description of the task space and their ability to find the toy, we also did a manipulation where the experimenter, while hiding the toy, used spatial words to help them encode. So we would say, I'm hiding the toy by the frog, when we're hiding it in the cup that was next to the frog. And we compared children's performance in that condition to one where we just said, watch, I'm hiding it here. We also had a condition where we just highlighted the location of the frog without actually talking about it. And we found that their spatial recall performance was helped most by the language where we said we're hiding by the frog, and not as much by the visual highlight. So that disorientation search test that I talked about here, where there's the colored wall, In another study with 4-year-olds, these researchers found that saying something like, "I'm hiding the sticker at the red wall," does help 4-year-olds find it after disorientation. But interestingly, in this study, it wasn't just spatial language that helped children. Children also benefited from a phrase like, "the red wall can help you find the sticker." So something that highlighted the relevance of this information without specifically using spatial words saying it was at or by the wall. But words like, or language cues like "look at this pretty red wall" did not help children. So it wasn't enough to just draw their attention to the red wall, but it seemed important to highlight how the red wall could be useful in performing the task. Another task looking at yet a different kind of spatial skill, it's called a relational mapping task. So in this task, there are 2 different little sets of shelves sitting next to each other, and the experimenter shows where they hide a little sticker behind one of those 3 cards, and then the child is supposed to find the sticker in the same relative location on the other set of shelves. So if the experimenter hides it on the top, then the child is supposed to search on the top on their shelves. This is a task that young kids, 3-year-olds, find generally difficult, but if you provide them with language like "the winner is on the top, in the middle, or on the bottom," that helps their performance. And they don't benefit as much from a different kind of language, where you say the winner is in, on, or under the shelf. So there seems to be some particular differences in the kinds of words that children hear. So the last kind of task I'm going to talk about is called the feature binding task. And this is looking at the relations between features on a single object. So in this task, the children are shown the object at the top, then there's a brief delay for 1 second, and then they're asked to find the one at the bottom that matches the one that they originally saw. And this, again, when we look at 4-year-olds, is a bit of a challenging task. So they often pick the mirror reversal at the bottom rather than remembering exactly how those colors were oriented. But if you tell them that the black is on the right, that improves their performance. If you tell them that the black is next to the yellow, that doesn't help their performance. So it seems important to highlight that it's on one particular side. And under some conditions, a phrase like "the black is prettier," which highlights an asymmetry between the black and the red, can help, but not under all conditions. So across these different studies, there's a suggestion that some types of language help in some types of tasks, but it's not a straightforward answer that only spatial language helps or all spatial language helps. So based on these prior studies, the questions that we're interested in investigating is the nature of the relationship between spatial skills and language. So we're interested in understanding whether children's spatial vocabulary, the specific words they know, are important, or if there might be a different relationship with different kinds of words that are relevant to the task. So when I talked about that disorientation search task, when the experimenter just says that the red wall will help you, that seems to draw children's attention in a way that helps their performance and isn't specific to spatial language. So we were interested in going back to these more correlational designs and trying to look at children's language use as it's relevant to the task, not just whether they're producing spatial words. And we're hoping that this can help us get at the direction of causation between the relationships we see in these tasks. So the studies I'm going to talk about today, there are 2 studies we've completed that I'll talk about first, and then if I have time, I'll talk about a few that we have in progress. So the first study was actually just published in Child Development, and we looked at the quality of children's language production in a spatial description task. And then we followed that study up looking at a related but non-linguistic task to see if that could explain some of the same variants that we found in spatial language. So the first study, we were interested in looking at preschool-age children. A lot of these prior studies that I mentioned looked at children who were about 4 years old, because that's an age at which their spatial vocabulary is really increasing, but their spatial task performance is still pretty variable. So this was the full range of 4-year-olds from 3 years, 11 months, up to 5 years, 1 month. And we included a number of different measures. So we were interested in their vocabulary. We were interested in their spatial skills on a number of different tasks that I'll talk about in a moment. And then we developed a new task, which we call the spatial scene description task, in which we were assessing the kinds of words that children would use to describe different locations. So this task, we have our little Bucky Badger pillow pet who is looking away from the screen. So children are watching a computer screen, and they're told that Bucky can't see the screen, but they need to tell Bucky where the mouse is. So we show them lots of different scenes where the mouse appears on one of the different objects. And their task is to use whatever words they want to describe where it is. And we use this to assess the quality of their language production, to see how accurately or clearly they can describe that location. And we did this by varying the relevance of different kinds of cues or different information across trials. So our manipulation of cue relevance. So here's an example where there's 3 different kinds of cues that children could use. They could describe the color of the box, the size of the box, or the location of the box. And all of those cues are equally accurate and precise in describing where the mouse is. Then on some trials, there were only 2 cues that could differentiate. So the one on the top right is showing you size and location. So all the beds are the same color. So in this one, you would need to use either the size or the location to differentiate. And the one on the bottom left is showing color and location. So now the 3 balls are all the same size, but you could use the color or location to describe it. And then the last time were the hardest trials, where only location words could describe where the mouse was. So location is always a relevant term. When you're asked to describe where something is, the location word can always be useful. But by looking at these other kinds of trials where you can optionally use color or size, we can see if children are sensitive to the relevance of this different kind of information. And because we were using kids who have a lot of variability in their spatial vocabulary, we arranged the objects on the screen always in this sort of diagonal layout, because that allowed children to use many different kinds of location words. So they could describe, for the soccer ball one, they could say it's on the bottom ball or the front ball or the right ball or something like that. So we wanted them to be able to use whatever spatial words they knew to describe the different locations. So for the spatial tasks, we use tasks that have previously been shown to relate to language. So the mental transformations task, which I mentioned before, where children have to pick the shape that would be made if you put the 2 pieces together. Spatial analogies, they have to pick the one at the bottom that goes best with the one at the top. The feature binding task, where they have to pick which of the 3 match the one that they saw in the first display. And then also a picture rotation task. So this, they're told to look at the bear on the left, and which of the 3 on the right would be facing the same way if we turned it right side up. And to measure their skills, we took their proportion correct across all of these trials, normalized for the different levels of chance, and just came up with one composite score for how accurate they were across all of the tasks. For vocabulary, we measured their general receptive vocabulary using the Peabody Progressive Vocabulary Test. So this is one where children are shown 4 words and they're asked to, or they're shown 4 objects, and the experimenter provides the word and they're asked to choose the one that matches. And we also developed a parent checklist that looks specifically at spatial vocabulary. So parents were asked to indicate which words they have heard their child produce in a spatial way. And this contained 80 spatial words, every spatial word we could think of, that we categorized in different ways according to what kinds of features they referred to. So to analyze our spatial scene description task, one of the first things we measured is just the number of words that children produced that were potentially relevant to the task. So this is the kinds of spatial words that have been measured in previous tasks, but we also counted the number of color words because color is potentially relevant in this task. So that was our measure of quantity of production, but we also measured the quality of their descriptions by looking at the relevance of the words that they produced. So we did this by subtracting their production of words that were irrelevant from the production of words that were relevant across trials. So here's the case on these 2 trials. If the child produced the word red, they would be relevant because that helps you differentiate among the different reference. But on these 2 trials, the production of the word red would be irrelevant. It does not help you differentiate among the different choices. So if a child produced the word red on all 4 of these trials, they would receive a score of 0 because it's +2 and -2. So we did that for both size and color words, and then we just added in any location words because location words were always relevant. So I'm going to give you some examples here from 2 different children and how they described these scenes across the different trial types. So this child said, on the little table. On the red chair. On the big bed. And on the middle basketball. We learned that not all children know the difference between a soccer ball and a basketball. So that's an example of one child that was the same child across all 4 of those trials. And now here is a different child. So this child said on the blue stool. And on the red rocking chair.
On the yellow bed.
On the yellow bed. On the red ball. So this is a child who chose to produce color words on all of these different trials. And this was typical of a lot of children in this sample. So we found that children really like to name the colors. But as I showed in the example with child 1, that child was more sensitive to the fact that color was not actually helpful on all the trials, and therefore produced different kinds of words to help differentiate on those trials. So in this case, child 1 shows more adaptive or relevant use of language, or a higher quality than child 2. So we used all of these different measures we had, so the production and the spatial scene description task, along with the vocabulary measures that I talked about, to try to predict children's spatial skills in a regression model. So we controlled for age and gender, as well as the different vocabulary measures. And then these two quantity terms, the quantity of non-spatial terms, that was color terms, because those are potentially relevant. And quantity of spatial terms was to see if we replicate prior studies in the literature. And we did find that the quantity, the number of spatial words that children produce, predicted their spatial skills after controlling for these different factors. But then when we also added in the quality score, how adaptive they were in using cues that were relevant, we found that that accounted for the same variance. So once you add adaptation to the model, then the number of spatial words is no longer significant. And instead, it seems to be more important whether children are choosing to use relevant terms. They might be spatial or they might not, but really what's key to predicting their spatial skills is their ability to produce relevant language. So this is showing the relationship between the adaptation score and the spatial composite score to show that we get a lot of variability along both dimensions in this sample. So from this, we concluded that spatial language alone did not predict spatial skills. So the number of spatial words was predictive, but not more predictive once you added in the quality of language production. So children's attention to the relevant dimensions was more important. So children could disambiguate locations using different cues across different trials, and that those children who adapted their production based on relevance were the ones with better spatial skills. So the question then comes as to what the underlying mechanisms are for this relationship. What we think is driving the relationship between children's language and spatial skills is their selection or attention to task-relevant details. And so in the next study, we were interested in testing this in a different kind of task. So when we take it out of a language context, can we see the same kind of attention to task-relevant dimensions in performance in a non-language task? So for the second study, we used the same general age range of participants. We increased our sample here because we counterbalanced a couple of tasks. We wanted to make sure we had adequate power to detect a potential difference in that order. Again, used a big range to get all 4-year-olds. And the measures we used were very similar to the study I already described. So the same measures of vocabulary. The spatial skills, we dropped the picture rotation task just because we were adding in a new task and needed to not be overly demanding on our child participants. We had the same spatial scene description task, and then we added a memory task. So the memory task we added was designed following that spatial scene description task. So we used the same kinds of displays for our memory array. So on a single trial, we would present the memory array, there would be a 1-second delay, and the child would be asked to pick from the 3 choices in the test array, which one matched what they saw before. So we tell children, look, the mouse is on the box, or the mouse is on the ball, the mouse is on the couch. And then at test, we ask them which box or which ball or which couch was the mouse on. And across different trials, the test arrays varied along only one dimension. So in the top example, we're showing what we call a color probe. So we're interested in whether they remember the color of the box. The middle is a size probe, if they remember the size of the ball. And the bottom is a location probe. And so for the memory array, we use the same 4 trial types that I talked about in the spatial scene description task, where they could be 3, 2, or 1 cue that differentiates. And then we crossed those 4 with all of the different probe types. So it's kind of a complicated design, but basically that means, like in the bottom example, where both color and location differentiated, but you're probed on location. On other trials, you might be probed on size, or you might be probed on color. So for this, we just took the children's overall proportion correct. How many times did they choose the correct object that matched the memory array? And we wanted to know whether this could predict their spatial skills in addition to those measures we already looked at. So when we do the same regression model I showed you in study 1, we again find that the quality of their language production, that adaptation score, significantly predicts their spatial skills. And again, that accounts for all the same variance that could be accounted for in the number of spatial terms. Oh, I should also mention that counterbalancing that I talked about. Because we use the same stimuli in the memory task as in the production task, or the spatial scene description task, we thought there might be an interaction between whether you had already described it and how your memory performance was, or possibly vice versa. But we found no differences in children's memory performance or their descriptions based on which tasks they saw first. So we just collapsed them together for our analyses. So then when we add the memory performance, the overall proportion correct, into the model, it accounts for much of the same variance that was accounted for by that adaptation score. So when we add the memory performance to the regression model, the variance that's accounted for by that adaptation score is no longer significant. It's marginal, so the p-value is 0.09. It's interesting to think about whether with a bigger sample we might be able to pick up on some more differentiation. But it at least seems that there is some shared variance between their performance on that memory task and their performance on the language task. And even though the two tasks require children to do different things, so in the memory task, you don't necessarily need to pay attention to the features that vary in the memory array because that's not predictive of what you're going to be tested on in the probe dimension. Oh, and here's the scatter plot that just shows the spatial composite by the memory performance, again to show that we get good variance along both of the dimensions in this age group. So we next did some follow-up analyses on the memory task. So if you look only at the memory task performance, we found a trial type by probe type interaction. So this is a pretty busy graph, but I promise I'll walk you through it and make it all make sense. So what we're showing here along the x-axis is the probe type. So that's in the test array what differentiated the three choices that children are given. So the examples I showed you were first color on the boxes, size on the balls, and location on the couches. And then we can look at how that varied according to what varied in the memory array. So remember, the memory array could have 3 cues, so the color varies, the size varies, and the location varies. It could have 2 cues where the location varies and color, or location and size, or 1 cue where only location varies. Now this doesn't end up being very many trials that goes into each of these different cells, just because we didn't want to have kids doing too many trials overall, but you can see a pretty striking difference depending on what varied in the memory array and what dimension they were probed on. So overall, we found that children were pretty good at remembering the color, regardless of whether it varied in the memory array. And on the flip side, they were universally pretty bad at remembering the location. And location always varied in the memory array, but whether there was other variability or not, they typically did not do very well on the location probe. But what I think is really interesting is looking at the size probe. That's where you get a differentiation depending on what varied in the memory array. So we looked at this by doing some follow-up analyses where we averaged together different kinds of trials. So we call this one the color size differentiated. So basically we put together the trials on which the probe dimension was a dimension that varied in the memory array. So for color, that's the 3Q or the 2Q color location. And for the size probe, that is the 3Q or the 2Q size location. I realize I probably should have put some pictures back up to help you put all that together in your mind. But basically we're asking, if the dimension varied in the memory array, did that improve children's memory? Or did that help them remember it and recognize it in the probe? So we can compare that with the same contrast but in the other direction. So when it didn't differ in the memory array, did that help or hurt performance when that was the probe dimension? So when size was probed but did not vary in the memory array. So that was like the example I showed you with the soccer balls. The soccer balls were all the same size, but you were probed on the size dimension. And then for location, we just looked at the location probes all together to have the same number of trials we were looking at in these different comparisons. So what we did is we took these 3 different subsets of performance in the memory task and asked which of those correlated with children's spatial skills in the other tasks. And we found that only the performance on the color size differentiated trials was predictive. So you can see also, if you look at my figure here where I've got the different colored arrows that are pointing, that was where children's performance was the highest overall, which I think is an interesting characteristic. It's where we see a lot of variability in their performance. But there was a significant relationship between memory performance on just these trials and their spatial score. Versus when we look at the undifferentiated, we still get a lot of variability across the children, but there's not a systematic relationship with their spatial skills. And what I think is the most interesting is their ability to remember locations was not actually correlated with their spatial skills, which you would think that that might be the dimension that's most relevant, but it didn't correlate here. I think it's actually because we made this task a little bit too hard for kids, that those location probes in particular were challenging. As you can see, their performance overall was not great. But we still did get a lot of variability across children. So I think it's an interesting question why the memory for locations doesn't correlate with spatial skills on our other tasks. So from this study, we found that the quality of children's language production overlapped with their memory performance when trying to account for their spatial skills. And there was a subset of memory trials in particular that predicted spatial skills best. It had to do with whether there was variability in a dimension in the memory array and if that dimension was what was probed on the test array. So our next step in this line is to try to understand these task limits a little bit better. So what is it that's leading some children to perform better than others on these different kinds of tasks? So the ones I'm going to talk about now, I'm just going to cover each of them briefly because they're studies that are currently going on in the lab, but to give you an idea of how we're trying to get a little bit closer to understanding the causal mechanisms that link children's language production and their spatial skills. So in one study, we are seeking to reduce the demands of the production task by providing the cues for the child and asking them to pick among the ones we've provided. In the memory task, we're looking at only one probe dimension at a time. So if you always know what you're going to be probed on, does that help children perform better? And then we're trying to get an assessment of children's attention to relevance in the spatial tasks in a non-linguistic way to see if there's a way that we can find evidence for attention that doesn't rely on language in particular. So to reduce demands in the production task, we have the same spatial scene description task, but now we tell the child that you can give different kinds of information to, now we have a pig instead of Bucky, and to help the pig find the mouse, which one the mouse is on, you want to tell the pig that it's on the red shoe, on the small shoe, on the bottom shoe. And we tell them they can pick more than one of these. And it's a little hard to see in the picture there, but we have a person of different sizes to help represent the size dimension. We just have a colored square to represent the color dimension. And then we've got this house that's in 3 different locations to represent the location dimension. So we're basically providing children with the 3 possible dimensions and asking them which ones they would pick to help the pig know where it is. So what we're trying to get at with this is to see whether children's performance is limited by their ability to select relevant information, or if it's limited by their ability to even come up with what the relevant information is. This is always one of the challenges in doing production tasks with children, is that when they fail to produce a word, you don't know if it's because they don't know the word, or they had a hard time retrieving the word right then, or they didn't think it was the right word to provide. So we're trying to get away from whether they didn't know the words or they had a hard time retrieving the words and really just look at their selection. So what I'm showing here is the proportion of children who chose each of the different cue types to provide. So like I said, children could provide more than one cue, but they didn't always. So if you look across the cue types, it won't sum up to 100%. But this shows that even when we provide these cues for children, they still have this preference for giving color information. So even when we tell them what the location words are that they could be using or the size words, they still have this preference for the color. And if we look back at children's production from the task that I just told you about, this is from study 2. So this is their production in the spatial scene description task when we don't give them any cues to pick from. And what you can see is that production is generally lower when we don't give them cues to pick from, but the pattern is remarkably similar. So we've boosted children's performance overall, but we don't seem to have changed whether they're sensitive to the relevance of the different kinds of information. So you could see here, there's a little bit of sensitivity to size in particular, and maybe a little bit of sensitivity to location. That purple bar is just a little bit higher, but it's not like children are universally choosing the relevant dimension. when we give them the words. So when we reduce those production demands, they're still showing the same general pattern of not being, some kids probably are sensitive to selecting the relevant information and other children probably are not. So we also are running a study where we're looking just at this memory task. And as I mentioned before, we had it in the original study where you could be probed along any of the 3 dimensions no matter what was shown in the memory array. So what we're looking at here is if we only probe 1 dimension per child. So if one child is always tested on their memory for the colors, another child is also always tested on their memory for size, another child on location, does that help them pay attention to the relevant dimension? And so what I'm showing here, now this is a different group of children for each of those probe dimensions. And we are seeing relative to, this is the data I showed you from study 2, we are seeing some subtle differences. We're probably going to need a bigger sample to know if these are really robust. But we do generally see that children are still best at the color dimension. They're a little worse at the size and they're overall worse at the location. But there's maybe a suggestion that always being probed on the same dimension is helping kids in some cases in particular. So like for size, the 2Q color location, that red bar, seems to be better in the single dimension probe, and location in particular in the 3Q. So those are cases where it seems like kids might benefit a little bit from always knowing what dimension is going to be probed. But again, it certainly did not bring their performance all the way up to ceiling. So it seems like there's still some interesting things going on with what kinds of information children are remembering in this task. And so the last new study I'll talk about is where we are trying to get a sense of whether children are paying attention to relevant information, even when they don't have words to describe that information. So this is using the mental transformations and spatial analogies tasks that I've talked about. And so what we do for these tasks is we have children go through and choose their answers on all of the trials. And then the experimenter goes back and reviews on every trial and says, okay, on this trial, you said this was the right answer. Can you tell me how you knew that? And then children describe how they picked the answer in this task. And so what we're doing is coding the spatial words they produce, and we're also coding how they gesture about the space. Because as I'll show you in a few examples, there are cases in which children are paying attention to information that they can't easily verbalize. But first, I forgot I have these figures in here. So we can also look at their production of spatial words, which is what prior studies really suggest are going to be important. And we do find relationships between their production of spatial words and how many they get correct in the task. So this is looking just at spatial analogies. So a proportion correct along the X, and along the Y is the number of orientation words that they produced. And so you can see a positive relationship that children who produced more orientation words were more likely to get correct answers. And this is because on a lot of those spatial analogies trials, that's the kind of information that's important. And what's interesting is we find in the same children a negative relationship with the number of shape words that they used. So these are 2 different types of spatial words, but they either help or hinder you in particular ways in this task. So I have an example here of one of the trials. It's a little hard to see, I apologize. But what this shows is the target is 2 triangles that are open at the bottom. And then the correct choice is the bottom right. It's 2, I guess they're sort of squares without bottoms that are open at the bottom. So what's relevant here is the direction they're facing, that they're open at the bottom, and also compared to some of the foils, that's relevant that they're the same shape as each other. So this is a case in which the specific shape words won't help you find the right answer, and in fact might actually be distracting. If you're too focused on the fact that it's triangles in the target, you might actually not be able to tell what the right answer is. So we think that shape words might be hurting kids because they're reflecting attention to irrelevant information in this task. But the orientation words like open at the bottom is what would help you pick the right answer on this trial. So we also can look at this in the mental transformations task. So again, I've got proportion correct along the X here. So in this task, shape words do help children, or they do correlate positively with their performance. So here's an example of one of the trials where a child might say that they knew the answer because it makes a square in the middle. So this is a case in which shape words are positively correlated with performance. And there are also particular kinds of words, spatial feature words, that might be helpful on a trial like this. So a lot of the trials in the mental transformations task The potential answers don't really have easy spatial words that we have in our vocabulary. So if I asked you to name what those 4 objects were, you would have a hard time coming up with a single word that describes the object in particular. But you might come up with words like, or you might talk about the points or the edges or something like that. So those are the kinds of spatial feature words that we're coding here to see how that relates to their performance in the task. So those two together suggest that there is a relationship between children's production of spatial words and their performance in the tasks. And what we were interested in finding across the 2 tasks, shape words related differentially to performance. So they were negatively correlated with spatial analogies performance, but positively correlated with mental transformations performance. So we looked across the 2 tasks and calculated a difference score. So if you as a particular child were more likely to use a shape word in mental transformation than in spatial analogies, that would be a positive score. Or if you use them equally in both, that would be a 0. Or if you use them more in spatial analogies, that would be a negative score. So we looked at this basically sensitivity to whether shape is a good feature to use in the tasks. And we found that that difference score correlated with their average spatial score across tasks. So here I've got the proportion correct is actually on the y-axis, so reorient from the previous figures. But we see this positive relationship, that children who were more likely to use shape words in mental transformations overall did better on both spatial tasks. So this is getting at that idea of selection that we were looking at in our previous studies of whether knowing which words are relevant and likely to help you in the task predicts your overall performance. So as I mentioned, we're also looking at children's gestures in these tasks to see if we can pick up on attention to relevant information when they maybe don't have the spatial words to describe it. So I'll show you a few examples of trials here. They're a little hard to see, but hopefully we'll be able to tell what's going on. So I've got the trial over on the right, and you'll see the experimenter is going to point at which one the child chose and ask the child to explain their choice. Oh, maybe, oh, media not found. Maybe not. So I can tell you instead what the child did. So in this particular trial, the child did make the correct choice, which is this one over here. So the relevant information to pay attention to is the direction that the 2 objects are facing relative to each other. So they basically need to have, you could either think of them as pointing out, if you think of the circles and the rectangles, or you could think of them as pointing in and having that symmetry axis in the middle. So it's a symmetric feature. So the 2 objects are basically a mirror image of each other. They will saw, so we had adults go through and describe the answers in these, and adults would say things like mirror image in this case, but very few children produced words that indicated symmetry or mirror image or something like that. I have a note here. So 11% of children use a term something like facing each other. So some children did pick up on that, but most children did not have words to describe that. And so what this child did here when he described it is he pointed to the choice that he made and he turned his fingers around the outside of the shapes. So he made a gesture that indicated he was paying attention to how those shapes relate to one another, but it was in a way that he couldn't really put into language. So I think, I don't have written down exactly, oh here, he said, because they both went like that. So that was the description that he gave. So in his words, he's not using a spatial word that indicates attention to that relevant dimension, but his gesture indicates that he knows this is the information he needs to use to find the right answer. So another video that you won't be able to see from that same child. So a different trial here. Now in this trial, the correct answer is the last one. So what's relevant for this trial is that the 2 objects slightly overlap. And that's the kinds of things that adults would say when describing this, but most children did not produce words like that. So, whoops, I'm looking at the wrong trial for my notes here. So yes, adults tend to say overlapping, but that's not a word that most children know. And so what this child said and gestured, he pointed to those 2 objects and he traced his fingers around to that point where they overlap. And he said, because they were both kind of in each other's space. So again, the words by themselves don't necessarily reflect the information, because you could say, well, there's other ones that are kind of in each other's space. But the way that he traced and paid particular attention to that small overlapping spot shows that he knows the information to pay attention to, but doesn't necessarily have the words to reflect it. So those were both examples from spatial analogies, and here's one example from mental transformations. So as I mentioned before, a lot of the trials in mental transformations don't lend themselves to really specific verbalizations. So if I asked you to give me a name for all of those 4 objects, you might say that they're like claw-type looking things or something like that, but you probably don't have words that really differentiate what the choices are. So finding the correct answer here depends on the exact size and shape of that curved piece at the bottom. And so those are the kinds of things that participants would say. They might say curved or they might say bottom, but they don't have specific words that differentiate among the choices. So this girl in her trial, what her gesture showed is, so she pointed at the top, she said they kind of like this and gestured down that triangle kind of angle at the top, and then she said, and they go, let's see what she said exactly, then around, and she gestured to exactly the shape that that bottom part shows. So she was gesturing to the top object, indicating the shape it made at the bottom. So again, not words that she specifically had to describe it, but a gesture that indicates that she knows that's the information she needs to pay attention to. Okay, so across those 3 studies, we're trying to find different ways to get at this question of what it is that really links children's language and spatial skills, and ultimately to understand what helps children's spatial skills develop. So when we reduced the demands in the production task, we found the same pattern that children, some children seem to be more selective in their production than others. When we use the predictable probe in the memory task, there may be some differences between when the memory probe was unpredictable, but again, we still get big variability in whether children remember different kinds of features. And in this last study, it seems that their gesture may indicate more than just vocabulary, that we might be able to find a non-linguistic way to assess attention to relevance in the spatial tasks. So across these studies, we can conclude that spatial skills relate to language in complex ways. It does not seem to be a simple story that once you have a spatial vocabulary, you can use that vocabulary to represent the words, or the spatial relation with your words. But instead, there might be underlying cognitive skills that are common with other tasks. So it might be children's ability to pay attention to what information is relevant in the context of the current task. And in order to uncover these relationships, we need to carefully analyze how different kinds of cognitive processes support behavior across the tasks. So if you remember at the beginning, I went through a lot of different kinds of spatial tasks that have been shown to relate to language. And those different spatial tasks require a lot of different specific skills. So we might find that there are different relationships between those tasks and language because of the different demands on different cognitive processes. And with that, thank you to those who participated, and thanks for your attention today. Time for questions? Yeah.
So I'm going to relate this to early childhood classrooms.
Yeah.
And in general, way of looking or working with kids to understand spatial relations is through vocabulary.
Right, yeah.
So what would you recommend for
Well, this is also relevant to me because I have a 5-year-old son. So I have, my kids are 2, 5, and about to turn 7. So I'm also sensitive to the need for spatial skills and thinking about when I'm describing things to my kids to help them try to find something. That there's a balance between using words that they know to help them kind of put things in the context that they understand, and then also supporting their ability to learn new words. So one of the things I didn't talk about actually is yet another study we have where we're looking at how children learn these different kinds of spatial words. So what we think might be going on is that one of the reasons that vocabulary correlates with all these different spatial skills is that in order to learn a spatial word, you have to know what information to pay attention to. So if we think about a complicated word like between, this is something that's hard for kids to learn, or middle is another one that's hard for kids to learn, because it requires understanding the relationships among multiple objects. And so learning those words can reflect your ability to pay attention to the information that is relevant. So helping children learn those words in particular, you can draw attention to the specific relations that matter. So talking about something being between, you can talk about how, you know, whatever you're referring to. So if it's between 2 chairs, talk about how the chairs are far from each other and there's something that's in between. But also I think keeping in mind what it is that children need to do in the context of a particular task. So when is relational information relevant to children? So if we think about, in my house, it's always like describing where someone's shoes are or where someone's mittens are that we need to find before we can leave the house. When we use words that they know well, so we can say it's in the red bin that's on the bookshelf or something like that, then we can support their use of the word on by using a cue like read that they already know. So we can combine this information and kind of keep in mind the things that kids do know, but also thinking about sort of pushing the boundaries of their spatial vocabulary and including those words in a context that they're more likely to understand. Does that kind of make sense?
So would you suggest, so I'm interested in the underlying cognitive processes that would be the foundation for a variety of things.
Mm-hmm.
So would you suggest activities that help children recognize what are relevant?
Yeah, so I think about like using the same word across different contexts to help kids pick out what's common across these. So you might think about, you know, if we're going to focus on learning the word between, then we're going to put the shoe between the chairs, and then we're going to move and we're going to put it between the boxes, and we're going to put it between something else, and kind of introducing a little bit of variability in the information that's not relevant, because that can help kids focus in on the information that is relevant. So definitely highlighting it with your own language, talking about why it is that this is between and that is between, but then also making sure that you're not always using one object with one kind of relation, because that might lead kids to pay attention to the wrong kind of information. So whatever information you don't want them to be paying attention to, change that information up, and then have reliably the information you do want them to be paying attention to, so that's what's constant across their different experiences. Yeah, Shannon.
I don't know if I can formulate this into an intelligent question, but I'm interested in that first study you presented where the infants, or the toddlers, seem to totally fail at the location priming piece.
So the location probe in the memory task or in the description task? Because they're kind of bad at both.
I think it was the memory, it was the objects.
Yeah, so if we look at,
locations and colors.
oh, here, let me find a figure for you. So in this memory task, so this is where they're probed on different dimensions. Yeah, and so when we look at the results here, if I show this proportion correct, they were really bad at that location probe.
So if you go back a couple slides to the images there, so so obviously location is salient to an adult viewer. And when infants are looking at, when toddlers are looking at this, they're sort of encoding it in this rich context where location, I mean, sure they could do some kind of absolute location thing, but more likely it's sort of a relative location.
Yeah, so I think this is exactly the issue. And it's funny because it aligns with like all of my other work on spatial reference frames.
I think you are the ideal person.
Like me of all people should have predicted that this would be the way that it happened, because what I think is really challenging for kids here is that we're presenting all of these on a big computer screen. And so the position of the couch in the frame here that's marked C, when we're showing the three choices, it's in a different place on the full computer screen. And so they need to really remember it basically relative to that little rectangle around it. And I don't think that's how kids are remembering this information. So they're not using the reference frame that we're trying to probe. So we as adults can all easily tell you which one is correct because it's in the top left corner of that box. But Hillary and I went back and we tried to look at the data in a different way, where instead we just looked at if the couch was on the left in the memory array, did they just choose the left choice? So when you show them three couches, even though where they are in those rectangles is not the same, is it maybe that they're just like, oh, it was, you know, the one on this side or the one on that side? And it's a little hard to tell because we didn't design the task to assess that, and so it doesn't perfectly align with, there are some times when the right choice is right in both reference frames. But when I coded it that way, there seem to be some kids who, if you code relative to the screen rather than relative to the rectangle, they did really well, and they did really poorly if you code it relative to the rectangle and not relative to the screen. So it seems like maybe kids are using different types of information. It's kind of like the right answer depends on what you think the question is.
Really sure, because I had that sensation when I looked at that, like, it felt like they were totally in space, and then I realized, oh, they're in the same locations as them.
Yeah.
So what if in the test array you have like the one you're probing and then two like little black dots that stand for...
Yeah, like where the other things were. Yeah, that's a good point, because maybe kids are encoding the couch relative to the other couches. That might be a different kind of reference frame that's actually the most likely thing that they're paying attention to. Yeah, that's a good idea because, yeah, we definitely went through some considerations of why it is that this is so hard for kids and why I didn't realize that, since some of my other work looks at how kids have a hard time selecting the relevant reference frame. So it certainly seems to be the case that, and I think that even relates to why spatial language is so hard. Because when we think about describing to someone where something is, we have to establish a shared reference frame first. So if I want to tell you that my keys are on the left side of my desk, it depends on whether you're sitting at my desk or whether you're standing on the other side of my desk. And adults are pretty good at accounting for that and taking that into consideration. Although even adults still make some of these left-right errors in particular. There's something particularly hard about that egocentric reference frame. Other things like saying something is above or below, because that's a gravity-defined reference frame, it's not as hard to establish that as shared. But there's some interesting work with adults, so I'm going to use my water bottle as a prop here. When you have an object that has an intrinsic reference frame, and if I tell you that something is above the bottle, but the bottle is at this orientation, then you might conclude that this is above the bottle or this is above the bottle, because again, it has to do with this reference frame and what it is that we're kind of sharing in a communicative sense. So there's some very interesting work on how reference frames are important for spatial communication that I think would be really interesting to get to eventually, because it seems to be layering multiple problems on top of each other, because now you also have to imagine what the other person means when they're saying something like above. And we know that for kids to sort of put themselves in someone else's shoes is already a challenging task, and that might be why left and right are some of the later learned spatial words, because they rely so heavily on this ability to put yourself in someone else's shoes or understand how it relates only to your body and not to other things in the world. It's actually a problem I have with my oldest son all the time. He doesn't understand walk on the left side of the road and ride your bike on the right side of the road. You turn around and go the other direction, now you have to go to the other side of the road, and he finds this incredibly confusing. And it's because of this exact reason of what is my reference frame. He wants there to be, this side of the road or that side of the road. He wants it to be defined by the road, and instead it's defined by the person, and that's really hard to understand when you're first learning how to use these kinds of spatial words. Yeah?
Are any of your tasks done with actual physical objects versus computers?
No, we have all the tasks we've done that I've talked about here are using these images on the computer screen and not using the actual objects. In that work that I briefly mentioned where we're looking at how kids are learning different kinds of spatial words, we did something similar. We have these, we call it a coloring test. We've got a bunch of circles on a page and there's like a star in the middle, and we ask kids to color the circles that are above the star versus the circles that are below the star. And we run into this exact reference frame problem that you have to kind of imagine now on my plane of the paper what's above versus below. And we talked about trying to turn that into a real object task, because when you're placing real objects in the world, there are constraints on where things can go that are probably really important to the way that kids learn these words. So when you talk about putting something on versus putting something under, that has specific physical relationships that they probably have experience with that we can't really capture in these kinds of two-dimensional computer screen images. I think for some kinds of words, the real objects are probably going to be more beneficial. But I think the biggest thing with why real objects might help is just because that's what kids are familiar with. That's what they hopefully are interacting with in most of their life, is not just pictures of things. Now, there are definitely picture books that go through different kinds of spatial relations, not as much. We were just talking about this today, actually. My kids have a Spot book where Spot is hiding in different places, and you have to, is he under the stairs, or he's in the piano. And so you do get some kinds of relations like that. But I think that the way in which kids learn spatial words definitely reflects the kinds of interactions that they can more easily have. So they learn words like in and on much earlier than other words, because those are really salient physical relationships that they've used a lot when putting things on the table, putting things in a bucket, those kinds of things. And so having that real life interaction with them, I think, helps make salient the information that's really relevant to the words. Okay, well, thanks again for your attention.
Thanks.